Hello. We're gonna build a pulse oximeter where you place your finger on the sensor and then you see your heartbeat rate on LCD or serial monitor. So basically, in this tutorial, I'm using Arduino startup kit, which has LCD, the Arduino board, the breadboard, and potentiometer. All the wires we need, everything inside it, except the sensor that you can provide it from Amazon or any other web store. You can find it anywhere. So without any further delay, let's just start building the hardware. It will take you around 40 minutes, 30 minutes to just get done, everything and see your rate there. It depends on how much comfortable you are with the board, but it should be fine. Just follow the tutorial. I will include all the steps in the tutorial, but if you have any questions, that just drop a comment. Yeah, so let's build the hardware. So let's see. Let's start by looking at the sensor itself. We are using this model, but the code that I use, it works for Max at 30, 100 as well, 100 and 102 and 105 maybe. But yeah, this is the one that we have. The boring part with this one is that it doesn't have the pins connected to it, so we needed to just make it like this, connected like directly to the wire. Actually, I had some other pins as well to connect it with. Wait, you can try these ones as well and connect it to the breadboard, but this one make sure that make it still also that it doesn't move. Well, in my case, it was moving actually, sort of, so the sensor was losing the connection constantly. So that causes like the values to be inaccurate. So it's better to make it this way. I just used simple wires and just connected these parts the way you see, bend them over. So this one has like the same pins in these two sides, the three any of them you can use. So one is the ground G and D, the yellow one, and then this one is VIN. So this VIN will be connected to VIN on the board itself here, and the ground goes here, and we have the three others. There is one, I don't know, is it INT or ENT? I don't know what, like one NT, whatever it is. This one it connects to number 10, and SD is connected to pin analog A4, and SCL is connected to analog A5 here. So I'll just go ahead and connect this. This is our first task, to just make this connected and work. I'm filming on my phone, so hopefully you see it. And this one is number 10. 10, 10. Okay, the ground. Oh no, sorry. What am I doing? Should be this way. No, let's make it this way. I didn't have so many different wires because I use lots of them on the LCD as well, so they're of the same color, but I hope it makes sense. So this one is G and D, so G and D goes to the ground. INT, the first one, it goes to like this, the opposite direction. Oh my god. Number 10, which one is that? 10. Yeah. So now we see SCL and SDA. I think this one was connected to A4, and SCA is connected to A5. And then look at my nails, they are so me see, VIN, so we connect this one. Sorry, it's really hard to keep, like, make it with, like, connect them in a better way, but I hope it does the job. I don't like the connections, but okay, whatever, it doesn't matter. It's better to just keep it this way. As you can see, we have connected this, and then I just use a USB and connect it to the computer. This is on, but okay, we don't see the what have I done? We don't see the LED to turn on. Let's see what's going wrong here. This one is connected. Number 10. Oh, I think these two are the wrong way, because ACL, I told you it should be to A5. Okay. Sorry about that. Hopefully it can see you. Yeah. So when I explained it the first time, I think I got it wrong, right? But yeah, as you can see, SCL is connected to A5, and it's the middle one. SDA, which is the corner one, it's A4. As you can see the red LED turn on, so that's a good sign that it's working. You can now we can go ahead and connect the LCD, but if you want to if you want, you can skip the part about LCD, because we can actually print all the values on serial as well. I'm going to show you using the libraries, the standard libraries. We can print everything on serial, and you skip the parts with the LCD connections. So I just move this, and let's look at the LCD. So I had connected this. Maybe I should remove everything, or let's keep it. It was really time consuming to reconnect everything, but I explain it this way. So the LCD has 16 pins, sorry. All of them are okay, one is here and 16 is at the other side. This LCD, it has the pins connected, but if your LCD has there's no pin, you can use these ones to put it on the breadboard and put the LCD on top of it. But again, with that as well, you need to make it stable so that it doesn't move. And then we have potentiometer, which you can, when we test it, you can see what it does with the LCD. So these two wires, they should go aside. What happened? This is, oh, let's see. The first pin of LCD is connected to the ground, and then we will connect the ground with this one to the Arduino board. The second one is to the positive. The third one goes to the middle leg of potentiometer. Let me show this. It has 3 legs, as all other sensors. So you can see that these 2 legs, either of them, you connected to plus and negative. I mean ground and plus, and then the third leg, it is connected to the third, which says V0, to the third pin on LCD. And then the fourth one, which is RS, it will be connected to 12, pin 12. And then after RS, there is R/W, that's the fifth one, is connected also to the ground. And then the sixth one, which is enable, it's called E here, it will be connected to 11. So these are D4 to D7. They will be connected to 2, 3, 4, 5. I mean the opposite direction, so this one goes to 5, and the other one, which is red, goes to 4 and 3 and 2. So the two last ones, they are for the LED. This LED negative, it's the ground, and then LED plus, which is the second one. You don't have to use a resistor, but it's better to use it to be safe. Like this resistor is 4K, 4000 ohm. You just connect it to the LED plus. But as I told you, if you don't have any resistors, then I mean, of course you do have, because of the starter kit, it has everything inside it. But yeah, that's it about the LCD. I hope it was like a good explanation, but let's go and connect this. I mean, I don't connect the ground and the breadboard to the current until I complete the full connection. So this one, I told you, this which is RS, it goes to 12. Now it'll be really a mess, but what can we do? Make sure that you keep track of the values, whatever. So this is the E, which goes to 11. These ones, this is the 7, goes to 2. This one is the 6, it goes to 3. The red one is the 5. This one is the 4, I guess, if you can see it. Yeah. Let's see. Yeah, I know it's really messy. I wish I had a better way of connecting them. You can use like these small pins to make it look cleaner. I think I should do that actually. Make it cleaner. It looks really messy now. I mean, who cares? Okay, whatever. You can see it's connected there, but it's not connected to ground and 5 volt. So the positive one, we connected to 5 volt on the board here. Okay, come on. As you can see, of course you can't see it. There is LCD. I'm sorry, I'm filming on my phone, so that's why it's really hard to show everything. But I try my best to just show it. This one goes to ground. There are 2 pins. Oh my goodness, I hate this mess. But do better wiring. Don't follow me with the wiring. I'm really bad at wiring. It's just I don't have. Yeah, ground, negative, and then this is 5 volt. Now you see that there is something going on here. Heart rate. So I was testing something, so it's there, but it's not running right now. So this one, actually, you play around with this in some computers. Like you don't need to like move this until the end. Maybe everything shows up at this point, but this one, in our case, it should be at the last part. If you don't see anything, just move this around a little bit to see what's happening. Right now it's text is there because I was already, I had connected this and like uploaded the code. So in your case you will see boxes here, like a bunch of boxes from this from here to there. If that's completely blank, then it's, yeah, make sure that you have connected the pins right. This part like these are the opposite sides. So D4 is connected to 5, and then D7 is connected to 2. So don't mix that up, because we tend to just connect them in order, but that doesn't work. So they should be in the opposite order. Yeah, this is the connection part. After running the code, we will see how it works. Let's check. Yeah, at the end of the video I will show the serial as well, serial monitor, but for this one it will be just on LCD. So this is the example with SpO2, and which is oxygen saturation, and also the heartbeat, heart rate. So the code is on their GitHub account. We can download it, and I'm going to show you how you. Oh, I have it opened here. So on their GitHub account, they have examples, they have the sources, the libraries that they use, the original libraries. You can have a look here as well. They use MAXrefdes117. So there are so many different libraries. This was the best one actually so far, because this is made from the original libraries. You have some examples here. SpO2 is the one that I'm using. Basic read, it just prints the number of pulses that it received. It's not actually pulse, so it's beats, and this will give you a range of like 90,000 or 100,000 beats, and that's like the raw data. On the heartbeat plotter, it will plot the heartbeats inside the Arduino plotter tools. This one, serial plotter. So you can use different like monitor, plotter, or LCD. I have used LCD, but if you wanna use just serial monitor and skip the LCD part, then just begin the LCD serial begin some like 9,600 or larger, maybe larger be better. And then instead of all of these instead of all of these LCD blah blah blah. I mean, with the heart it doesn't work because you need to print something. It's easier on the serial printer, so you just print a heart shape. Take it from internet somewhere. Just print. Then you can skip these parts on serial. But here when it says print heart rate, just replace these lines with serial, then you will have them on serial monitor. Well, in my computer it was like I run it on Linux. Right now I'm just running it on Mac because it's easier to edit the video later on. But the video that I showed you, the demo, it was running on Linux stationary computer. So even in that one, serial and LCD, both of them, like, I mean, it doesn't work together. So just better to just use LCD or serial monitor. And also these two tools, you can't keep them open together. So either you use serial monitor or serial plotter. You can combine like those two examples that have basic read, not basic, I mean all of them, but then heartbeat plotter, you can combine it with this one, and then when you want to see the plotter, then you can use the plotter tool, and like if you want to use monitor, then open it in monitor. I don't want to test it on this one, but you get the basic ideas here. So one more point about their own original library, which is MAXref. I have googled it like so many times now. So this one, it claims that they provide the source code to make it easier to use the sensor. So all the code, everything is here. You can download them. I already have it. It's not actually working. So it's really sad to say that, but this original, I don't know. I mean, in some tutorials, they show that it works, but not in my case. It didn't work, and it shows so many different errors. And the errors I really tried to solve, it was just errors that it could not recognize this, it couldn't, like whatever I was trying to remove or change, it would cause so many more problems. So I tried this one, but here it has the library and like all the necessary parts. When you open it, you see this, but it doesn't work, so don't use it. um I mean, basically now it's so many other libraries that they have used the code here from some better libraries, and the one that I used right now, it's just taken from the original ones, and a simple basic code that does the job that this thing does, but it will not run because it's just, you see, this is a small error, and then if I go to this place that it refers to, and then I comment that part, for example, not okay here, it doesn't say like that, but if you run it on Windows or Linux, then you will see like so many lines of errors. Yeah, this was about the original one. So there is another library as well, which you can use if you want. There are like so many different links for it, but originally it's MAXrefdes117, so you can go to their website and play around with the code there as well. So yeah, this was the code for the tutorial. It's not really a big explanation, just explaining the code from the library. So thank you for watching. I hope it was useful. Please leave comments if you have questions. Yeah, I will add some other videos in this series as well, why this doesn't work, and like possible errors and stuff like that. So stay tuned, and see you in the next videos. Thank you. Bye bye.